Okay, so I want to first remind everyone to check their grades. The weights may have changed your score, but if you want a homework extension, let me know. Extensions are okay up till the last day of class. Which is 5, 21. And I made homework. So there's 4 short assignments. It's sections 4.2, 4.3, 4.4. And 4.9. They are due on Sunday, but again, if you want more time, let me know. And that's going to be Sunday the 9th. Let's talk about, I think that's it. Just mentioning again that we only did 2 quizzes this semester. This is probably the last of the homework. I would like to make chapter 5 homework, but it will probably be like practice and not part of your grade. We'll talk about it if it actually happens. Okay, so I want to finish 5.2. So there's a problem that we started and are going to finish. I want to state a theorem first, and then after this example or two, we have a list of properties, and that's the end of the section. There's been a note that this is for using right-hand endpoints when you're finding your integral. So if f is integrable, on AB, then the integral from a to b of f. So then the integral from a to b of your function f of x dx is the limit as n goes to infinity of the sum from I equals 1 by equal to 1 up to n of f of x sub I. We're going to do x by star. Delta x. And when you're doing right-hand endpoints, we can talk about what x of I star is. Of course, delta x is b minus a over n. And your x of I star is going to be the place you start, a, and add I times delta x. Okay, so we should have seen this before. Again, the integral from x equals a to x equals b of your function f of x with respect to x is the limit as n goes to infinity of the sum from I equals 1 up to n of f of x of I star delta x. X of I stars are sample points, and we're talking about right-hand sample points. And in that case, you've got your like x values. You integrate from a over to b. We call the starting place x naught. You end at x of n. And then you add delta x, and that gives you x1. Another width of delta x will be here at x2. Actually, I'm going to put from here to here. We're adding delta x. So this is a plus 0 delta x. This is from here to here. We've gone from a and we've added 1 delta x. From a going here and here, you have a plus 2 delta x. Until you go dot, 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 dot. Somewhere here you have x sub I. Let's put it like this. X sub I would be starting at a and adding delta x I times. So a add I times delta x. Like say the very first one, when you put in I equals 1, x sub 1 equals a plus delta x. Where's trying to go? Oh, I see. So that first one is right here on the right side of the first interval. So it's a right-handed point. Okay, so we're doing an actual problem. We have the integral from 0 to 3 of 25 minus x squared. So we took this and, well, we can always restate the problem. Is, okay, the limit as n goes to infinity of the sum from I equals 1 to n of f of x of I star. We're going to go ahead and put the whole thing, delta x. Okay, our x of I stars are going to be maybe we'll put that as scratch work on the side. Yeah, we need some scratch work. Let's go over here. Yeah. Okay, first thing I need is delta x. And it's 3 minus 0 over n. Okay, my x of I stars are going to be, what was that theorem? A plus I delta x. Okay, so we've got A equals 0. 0 plus I times 3 over n. So x of I star is 3i over n. And we're putting that into your function. So go ahead, limit. As n goes to infinity, of your sum, I equal to 1, go up to n. F of 3i over n. And then delta x is 3 over n. Cool. Limit sum function delta x. So let's put that into our function. 3i over n is going in for your x value, so this is going to be the limit as n goes to infinity of a sum from I equals 1 up to n of 25 minus 3i over n squared and 3 over n. Cool. I'm just going to write a step where we square this part. So we have the limit as n goes to infinity of the sum from I equals 1 to 25 subtract 9i squared over n squared. Okay, distribute that. So the limit as n goes to infinity of the sum from I equals 1 to n of 75 over n minus 27 I squared over n cubed. Okay, cool. And we talked about summation rules. So the part that we need to worry about is anything with an I. So if it's a number, we can bring out the number. If it's n, you can bring out n values. But if it has I, it has to stay in the summation sign. And I think I want to do a step where we break up the summation. Okay. So we're going to do the limit as n goes to infinity of the sum from I equals 1 to n of this term and the sum from I equals 1 to n of that term. So let's do too much. Actually, we don't need the limit twice. So what we're going to do is have the limit out here just one time and bracket this. And I just want to break up the sum part. So I am going to leave this here. Sum of that minus the sum from I equals 1 to n of the 27. I squared over n cubed. Okay, cool. Then I'm going to go ahead and I'm going to bring out 75n, which leaves 1 behind. Then so we sum from I equals 1 to n, the number 1. Minus. We can take out 27 over n cubed, and I squared stays inside the sum. So we can do the rule, the sum from I equals 1 to n of a constant is the constant times n. So 1 times n is this value here. So this part is 75 over n sits there. This sum, it sums to n. 27 over n cubed stays. This sum we talked about, the sum from I equals 1 to n of I squared is, let me make sure I get this right, n times n plus 1 times 2n plus 1 over 6. And then this part simplifies. You got this 27 over 6 is going to be 9 over 2. And then there's an n squared in the denominator. Simplify this part. Okay, 75 minus 9 over 2. This leaves n squared down here. And then we've got to FOIL n plus 1 and 2n plus 1. So 2n squared. Add 3n plus 1. Okay, so we want to have this split up into 3 terms, and then we'll probably be taking the limit after that. From here to here. Actually, I think I want to write out that whole numerator first, and then, so I've got one more step. This is a little in between work. Okay, so 18n squared over 2n squared is going to be 9 minus 27 over 2n minus 9 over 2n squared. Cool. Then we can have n go to infinity. So this is a number over something growing bigger and bigger and bigger, which means this goes to 0. Same here. This number is fixed. This value gets bigger and bigger. So this goes to 0. And the limit is going to be 75 minus 9, which is 66. There's one more example like this. We integrate from 1 to 3. And the function is x squared minus 2x plus 5. dx. Okay, let's go ahead and focus. Okay, scratch work. I would like to use right endpoints. Okay, delta x is 3 minus 1 over n. Okay, x by star is a plus I times delta x. Okay, so here we start at 1. 1 plus I times 2 over n. Okay, so I can write my integral. Which will state again. The integral from 1 to 3 of x squared minus 2x minus 5 is the limit as n goes to infinity of the sum from I equals 1 up to n of f of x of I star, f of 1 plus 2y over n. Times delta x, which was 2 over n. And we have to put this into the function for x, which means it goes here and here. So we're going to have the limit of the sum of 1 plus 2I over n squared minus 2 times that number minus 5 times 2 over n. Just checking. This is in there for x, and I get it again, and it's all good to go. Cool. So let's square this. So you get 1 times 1, which is 1. plus 2i over n and another 2i over n, which is 4i over n. Add 2i over n squared. So 4i squared over n squared. Okay, so and then minus 2 and minus 4i over n. And minus 5 times 2, all of it times 2 over n. Let's see, there's a positive 4i over n and a negative 4i over n. And all the numbers go together. So we've got 4 plus 4i squared over n squared. It's supposed to be plus 5. There's supposed to be a plus. Yeah. So just a reminder, my function is x squared minus 2x plus 5. And we're good to go. Next, we need to distribute the 2 over n. We sum I equals 1 of 2n of 8 over n plus 8i squared over n cubed. And after that, we're going to have the sum applied to both parts, which we'll just do in one full step, and then afterwards we can bring out values that aren't affected by the I. Okay, first, let's make up this. Okay, the limit as n goes to infinity of the sum from I equals 1 to n of 8 over n plus, and the limit's going to apply to this whole part, plus the sum from I equals 1 to n of the second term. Okay, here, got the sum, and that sum, correct plus sign in the middle. Limit as n goes to. So 8 can come out, so can 1 over n. So the whole value 8 over n is outside of your summation that goes from I equals 1 up to n. And you left 1 behind. Here I can bring out 8 over n cubed and leave I squared inside. So. Okay, the sum from I equals 1 to n of 1 equals n. And there's an 8 over n cubed times that sum, which is, I just did this one. It's n times n plus 1 times 2n plus 1 over 6. Cool. So this is 8. And then we're going to figure out what this is. I know that this reduces 4 over 3. Cool. 8 plus. This divided by 2 is 4, that divided by 2 is 3, and then I've got this n squared in the denominator. We're going to FOIL out this one, which we've done before. We've got 2n squared plus 3n plus 1. Okay, so after that, I expand the numerator and then split everything up into separate terms and then find the limit. Okay, so 8n squared. Add 12n, add 4 is over 3n squared. So limit as n goes to infinity of 8 plus 8 thirds plus 12n over 3n is going to make this 4 over n plus 4 over 3n squared. Then you can do the limit. As n goes to infinity, this fixed number over that number growing bigger and bigger goes to 0. Same thing here. So we've got 8 plus 8 thirds. Which is 32 over 3. And I think I'm going to write it as just finish. We're done. Okay, let's go. So for the rest of the notes, it's just a list of properties. There are 6 total. So just a reminder that the integral from a to b of your function is the area from that beginning place to the ending place under the function to the x-axis. So if you integrate from a to a for your function f of x, there's going to be 0 area. Also, if you have your integral from a to b of f of x dx is equal to the negative of the integral from b to a of f of x dx. So that negative sign lets you switch the interval of integration to being from b to a. Okay, let's read. Number 3. The integral from a to b of some number c. It's equal to that number c times b minus a. Next one is going to be 4. And we're going to have the integral from a to b of a constant times your function, c times f of x dx. So you can bring the constant out front and multiply it with that integral. That goes from a to b of f of x dx. Let's try to put 5. Okay. No. The next ones need space. Well, I'll give you a moment to write this down. Let's put down like an example. We'll actually work through something like this later, but if you go from, let's say, integrate from 0 to 1, 5x squared dx, you write it as 5 times the integral from 0 to 1 of x squared dx. Okay. The integral from a to b of f of x plus or minus g of x. So two functions, add them or subtract them. You can integrate from a to b f of x, then add or subtract the integral from a to b of g of x. F of x dx. Add or subtract the integral from a to b of a function g of x dx. And the last one is if you want to take your integral and break it into different parts. So you can take an integral that goes from a to b of f of x dx. And integrate from a to c of f of x and add the integral from c to b of f of x. So we can integrate a up to c of your function. As an integral that goes from c over to b of your function. A is less than c, and that's less than b. So quick sketch, and then that's kind of it. You have some x values, and you're integrating from x equals a over to x equals b. And c is somewhere strictly greater than a or less than b. So find the area under the curve from your function to the x-axis for the interval from a to c, and then add the area that you find that's on the interval from c to b. Cool, that's the end of 5.2. I think that's the end of the notes for today. Let's see. Yeah, okay. So that's the end of class. Thank you for coming to class.